Hi, Assalamualaikum warahmatullahi wabarakatuh. We are from Group 1, CHM3501, SCL, Surface Coating, Pigment. My name is Amani Hoina binti Hassan and my metric number is 202982.
My name is Nora Ashika binti Rizwan. My metric number is 202983.
My name is Auni Nabiha binti Paiman. My matric number is 200676.
Hello, my name is Nur Hayatna binti Mukhni. My metric number is 2006.
Hi, my name is Muhammad Arif Fikri. My metric number is 200326.
My name is Nur Nisha binti Chaini and my matrix number is 203891.
So I will start about the introduction about pigment. Pigment is a material that changes the color of light it reflects as the result of selective color absorption. A pigment must have a high tinting strength relative to the material color. It must be stable in solid form at ambient temperature. Pigment are used for coloring paint, ink, plastic, fabric, cosmetic, food, and other material. Most pigment used in manufacturing and the visual art are dry colorant, usually ground into a fine powder. So what is the difference between pigment and dye? Both pigment and dye appear colored because they absorb same wavelength of light preferentially. Yet a distinction is usually made between a dye and a pigment. A dye is either a liquid or is soluble in the vehicle, resulting in a solution. By contrast, a pigment is insoluble in the vehicle, resulting in a suspension. In addition, a dye binds to the substrate, but a pigment generally has no affinity for the substrate. Pigment color has been used for an ancient time and it's been recorded before Industrial Revolution. The range of color available for art and decorative use was technically limited. Most of the pigment in use were earth and mineral pigment or pigment of biological origin such as animal waste, insect and mollusks. Example of the color created by biological origin is Tyrian purple. Tyrian purple is a pigment that made from the mucus of one or several species of mullet snail. This method has been introduced as early as 1200 before Common Era. Uh, and the synthesis pigment was developed for a purpose to find a less cost pigment. In 74, by accident, the first synthetic pigment was discovered. Then by the early 19th century, synthetic and metallic blue color blue pigment has been added to the range of blue, including French ultramarine, cobalt, and cerulean blue. The discovery in 1856 of Mauvin, the first purple aniline dye, was a forerunner for the development of hundreds of synthetic dye and pigment. And okay, next slide. Okay, this the self-portrait of Paul Season. This picture was created by the color that that was earlier. That was been created earlier at the late of 19th century. Okay, I will be pass presentation to Hayat.
Okay, next I will proceed with the industrial development of pigment in the 20th century. So in this century, pigments increasingly became a subject for scientific investigation and research found that in this century there were new synthetic colored pigments that came to onto the market, such as cadmium red, manganese blue, molybdenum red, and mixed oxide with bismuth. And there are also new synthetic white pigments and fillers, which are titanium dioxide with anatase and rutile structures and acicular zinc oxide. And there were also luster pigments. So luster pigments is assumed to have increasing importance because they have metal effect properties, nacreous, and interference pigments. So in this 21st century, pigment production is still a growth industry where the suppliers put the customers' demand in the first place, and they must always able to respond to the customer's need. So there are several aspects that the suppliers need to consider, and as well as for the customer when choosing a pigment for particular application. So the number one is the coloring properties of pigment that encompasses the color, the tinting strength or lightening power and hiding power. The second one is the general chemical properties and the physical properties of the pigments that encompasses the particle size, density, and also chemists, also the suppliers must observe the stability properties of the pigments in terms of resistance to heat, weather, and light. And the fourth one is the behavior of the pigments in binders. So this is an observation on the interaction with binder properties, dispersibility, etc. So in this 21st century, we could see a lot of application of pigments, especially in coating industry. So for example, in automotive coatings, effect pigments continue to develop faster than regular colored pigments. And in industrial coatings, demand for premium, durable, and weathering resistance of pigments continues to be essential. So nowadays, coating manufacturers are more focused on delivering highly durable, sustainable, functional, and cost-effective solutions for pigments production. So here are several new additions to the industrial pigments. So we could see there are pigments companies that took or paint companies took more emphasis on the waterborne paint system in automotive paints, which this type of paint appear to be less toxic paint than the solvent-based paint, and it also has advantages on reducing the emission of VOC, which is volatile organic compounds. So there are also companies that make offerings. The company is Sun Chemical Company. So this company has designed a family of organic pigments to replace inorganic pigments. So this family of organic pigments have smaller environmental footprints based on do more with less approach. So this family includes Sun Bright Yellow 74, Fastogen Violet 23, and Quindel Red 122. So they have environmental benefits on higher tint strength. So this allows the formulators to reduce the usage of raw materials. So the reduction of usage of raw materials can improve the environmental aspects, such as CO2 output and the energy reduction and packaging and shipping. So there are also in this century now there are creation of X-Fast Easy Color collection, which is the first dry stir-in pigment preparation for the POS markets. So these pigment preparations actually is a method for prepare pigments, and it simplified coloring dispensing systems, which promote clean and easy handling to prepare pigments. So next, I will pass the presentation to Amina Biha to explain about the classification of pigments. Thank you.
Okay, for the general properties, Usually pigments are divided into two parts, which are organic pigments and inorganic pigments. For the general properties for organic pigments is high color range, and white inorganic pigments has a weak color range, and organic pigments has a bright shaders, while inorganic a dull shades. Organic has high light fastness and inorganic has a low light fastness. Good weather fastness for organic pigments and inorganic has a low weather fastness. Organic is a transparent while inorganic is opaque. Organic has a little degree of solubility while inorganic pigments is insoluble in solvents. And organic has a more varieties of chromatography while inorganic has a less varieties. Organic also has a wider spectrum and inorganic has a narrow spectrum. Organic pigments usually non-toxic and has a low toxicity, while inorganic pigments has some varieties has high toxicity and some varieties has a low toxicity. And the last one is organic pigments has the higher cost rather than inorganic pigments. I will pass to Nur Ashika.
Okay, so I would like to talk about the raw material of pigments. Okay, firstly, there are some of pigment are formed in nature, in mineral or vegetable forms, but most of them are synthetic materials produced from variety of chemicals. And then it also manufactured from non-renewable raw materials such as coals, oils, and natural gas. And it also obtained by quarrying, or we call it as extraction, such as titanium dioxide or iron oxide, or from oil product. And then pigment are composed of tiny solid particles less than 1 micrometer in diameter that enables to refract light, which light have wavelength between 0.4 micrometer and 0.7 micrometer. So pigment also can be classified as organic, inorganic, and metallic. And then followed by the blue pigment actually was derived from lapis lazuli. Then red ochre, which is anhydrous iron trioxide, was hydrated and it will form yellow ochre. Also carbon black, or we call it as a charcoal. It has been used as a black pigment. Next slide. For the raw material of the organic pigment is actually obtained by synthesis of aromatic hydrocarbons that contain structure of carbon atoms with hydrogen atoms that attach together form in close ring, and then followed by black pigment, which is an example of organic pigment. It is primarily created from particles of carbon, and then for azo pigment, which also another example of organic pigment that contain nitrogen group, and it account for most red, orange, and yellow pigments. Next, for the synthetic organic pigment, it is manufactured from coal tar and other petrochemicals, and the requirement of bright shades used to show it actually have. Okay, so for the inorganic pigment is manufactured by simple chemical process such as oxidation, while white pigment is such as lithophone is such example of inorganic pigment which is mixed with zinc sulfide and barium sulfide that contain 30% of zinc sulfide, and then followed by titanium dioxide, also another example of inorganic pigment that produced from ilmenite, rutile, or titanium slag. So titanium pigment is extracted by using sulfuric acid, which undergoes sulfate process, or chlorine that undergo chloride route. So based on the information, the sulfate process is employs simple technology than the chloride route. So next, about the metallic pigment, it is about from metal. It is formed from metal pigments such as zinc, and aluminum pigments. So last but not least, organic, inorganic, and metallic pigment are widely used in industrial application today. So that's all for my part. I will pass to next presenter.
Okay, for the classification of pigment, there is divided into two parts, which are organic pigments and inorganic pigments. The example of organic pigments is polycyclic pigments, anthraquinone pigments, quinophthalate pigments, diazyme pigments, azopigments, and triaryl carbonium pigments. For example of inorganic pigments are white pigments and color pigments. The example of color pigments are ultramine, cadmium, and iron oxide. Okay, for organic pigments are based on carbon chains and carbon rings. They also contains metallic, which is inorganic elements that help stabilize the properties of the organic components. So the color that usually involved in organic pigments is yellow, orange, red, violet, blue, or green. Okay, for the example for organic pigments is diacetyl pigments. It's produced violet coloration. Combination with phthalocyanine blue pigment produce a very reddish shade derived from triphenodiazine, which is a linear system of 5 annihilated rings. It has a light and weather fastness, excellent solvent and migration resistant, and the commercial application include the pigmentation of plastics, printing inks, spin dyeing, and coating. So this is a example of the chemical structure for diacetyl pigments. Okay, the next one. The next example is isopigments. It is the largest chemical class of compounds. The hues of the isopigments range from red, yellow, and orange to blue. And isopigments has excellent color properties and has a good light fastness. So this is the example of the isopigments chemical structure. The next one, the next example is polycyclic pigments. It is a non-azo pigments, aromatic or heterocyclic ring systems. It has good weather fastness, more expensive than azo pigments, used in all application paints, plastic, cement, and textile products. The examples is isoindolinol pigments and phthalocyanine pigments. So this is the example of the chemical structure for phthalocyanine pigments and chemical structure for isoindolinol pigments. Next. Okay, the next example is anthraquinone pigments. It has a good stability and solvent resistant, has a moderate good light fastness, and has a bright and strong color. The color of anthraquinone pigments is red, and the chemical structure, and there is a chemical structure for anthraquinone pigments. Next one is quinophthalate pigments. It has a good heat stability, good solvent resistance, and has excellent light fastness. The color of quinophthalate pigments is yellow color, and this is the chemical structure of quinophthalate pigments. And this is a triarocarbonium pigments. The color covers from green, violet, and blue. There has two types which are salt of triphenylmethane sulfonic acid and salt of heteropoly acid with tungsten, silicon, or iron. It has a poor solvent resistance, limited light fastness, excellent color brilliance, and the commercial application for printing inks, especially for packaging inks. So the chemical structure for tricarbonium pigments. Okay, next. Okay, for inorganic pigments is a chemical compounds that not based on carbon and is usually metallic salts precipitate from solutions. The color that usually involved in inorganic pigments is brown, black, and white. Next. Okay, for the white pigments, inorganic compounds of titanium. White pigments is inorganic compounds of titanium, zinc, antimony, or lead. The example is the titanium dioxide. It's used in paints. White lead, like lithophone, basic lead carbonate, and zinc oxide like antimony oxide and titanium dioxide were widely used. Next. The next one is the color pigments. The example of the color pigments is ultramine. It has a blue color, high light fastness, excellent resistant to alkali and all organic solvents. It is non-toxicity and has a poor resistance to acids. The chart one is the how blue ultramarine form, which is from sodium carbonate react with alumina and silica to form a zeolite. And then zeolite will react with sodium polysulfides to form a green ultramarine. And then green ultramarine will coal into the furnace to form a primary green oxidizers and form a blue ultramarine. Okay, for the next example for color pigments is cadmium. It has a better solvent fastness and high fastness to migration like plastics and polyolefin. The color of cadmium is orange, which is a combination color with cadmium red light with cadmium yellow medium. Okay, the last one for the color pigments is iron oxide. It has a largest class of colored inorganic pigments. It is non-toxic, low price products, and the wide range of shades are yellow, orange, red, and black. So this is the example of the color iron oxide. That's all from me. I will pass to the next presenter.
So I will continue with the methods in producing inorganic pigments. Firstly, the composite oxides are sintered at a low temperature for a short period of time, which will allow the pigment in the melts can reach its best possible pigment properties, which results in homogeneous and well-colored pigment. And then the oxides of elements will be mixed to constitute specific inorganic pigments or compounds that can be converted into such oxides under heat in predetermined ratios. And then the raw materials are dry processed in a grinding machine without being subjected to mixing step. Thereby, it will give the raw materials sufficient energy, which is enough to induce the mechanochemical reaction of the materials to compound them into composite particles comprising the raw materials in the compounding ratios. So these are the examples of the inorganic pigments with the mixture of oxides. So the first one is the green inorganic pigments, which is made by mixing titanium oxide or metatitanic acid with oxides of elements of cobalt, nickel, and zinc. The second one is yellow inorganic pigments, which is produced by the mixing of titanium oxide or metatitanic acid with one or more of oxides of cobalt, chromium, and nickel. And then the last one is the blue inorganic pigments, which is produced by the mixing of raw materials comprising cobalt hydroxide or cobalt carbonate as the cobalt source and aluminum hydroxide as the aluminium source. So next. Okay, so this is an example of the apparatus used in the production of inorganic pigment. Because it is preferably carried out in continuous flow apparatus, for example in this picture, which is a siphon light heated discharge tube that is provided in A. Okay, so inside the apparatus A, it is provided with a very efficient stereo mechanism. So first, the dry crude pigment from B and also the crude pigment in melt in C will be continuously provided to A, which will then be processed. And then the method of recovering the final product in an effective and economical way is by the melt is discharged from the siphon of that is connected to A, which will then either led through the special heating filter or centrifuge, or in other words, it is separated, which makes the melt freed from the pigment, and then the melt will be supplied back into continuously, and then the cycle will continue. So I will pass to the next presenter.
Okay, sorry. Next, I will continue with production of organic pigment. First, nitration. This reaction is carried out in cast iron, stainless steel, or enamel line mill steel reactors. The temperature vary normally between 25 to 100 degrees Celsius. And okay, the nitration starts with substrate is dissolved in the hydrogen sulfate, and then the and mixed acid is subsequently added, and then the completion of reaction is occur aspiration, where it transfer into water to form two phase, which is diluted acid phase and also organic product phase. And then liquid product are purified by using distillation, and the remaining acid phase can be extracted with the feed material in order to recover organic compound. And then nitration also, after the nitration, it also the solid product are crystalline, where necessary by the addition of cool water. Next is filtrate, and then the product, the crude natural aromatic is washed with water and diluted sodium hydroxide to remove acid and phenolic byproduct. Depending on the quality requirement, recrystallization from water or organic solvent may be necessary. Isomerization is carried out within the crystallization, washing, or distillation step. Next, the next process of organic pigment is alkali sulfide reduction. This reaction is mild and selective reaction. The other reducing agent is used are sodium sulfide or sodium hydrosulfide that also form sodium thiosulfate. Sulfur may be added to reduce the required amount of sulfate. The reduction starts with dilute aqueous sulfide is added to the solution or emulsion of the nitro compound. The temperature is 80 to 100 degrees Celsius. The concentration depends on the reactivity of nitro aromatic. Excess of sulfide is avoided in the case of the selective reaction of polynitro compound. The workup depends on the properties of the amine obtained. The common methods are separation as a liquid, cooling and salting out, steam distillation, extraction with organic solvent, and pH adjustment if necessary. I think that's all from me. That's all from our group. Thank you.